Today you will continue to work with data, and from here to the end of the course we will work together with data using Python. My name is Nan. I will accompany you from this lesson until you graduate from this course. Before working with Python, we will together go through a library that is very important and is the basis of working with data and Python, which is NumPy library. Before starting to learn about NumPy library, we will begin with a question. Let's ask ourselves about where data comes from in our lives. Speaking in the programming language perspective, your data can come from all sources. Your data can come from transactions when you buy goods online. For example, you ship a product from the warehouse on the Shopee app, or you check in at the plane ticket counter. You are leaving data somewhere in your life, and your data has been recorded in the data systems. That's the data we usually think about. However, when it comes to programming languages, we will divide data into two types: unstructured data and structured data. I will repeat, they are unstructured and structured data. Unstructured data is data in the form of images, text, audio, or videos, while structured data is the tabular form of rows and columns which you have encountered in the previous SQL module. So here, if you look at the unstructured data, we have text, we have images, we have audio. Then how will the computer handle these things? Now we will talk about data in the language of the computer. The computer will view your data using vectors and matrices. So now when we start learning how to use Python to work with data, we will no longer look at data in the form of tables in the database, but we rather look at these data as in the form of vectors and matrices. For example, as what you are seeing on the screen, we have a data table that includes columns such as country name, country code, birth rate corresponding to those countries, internet user corresponding to those countries, into different vectors. For example, when you take the birth rate column separately, you will have a vector containing 5 components like this. Or when you check a row of this data table, such as the Aruba country row, you will also have a vector containing these 5 new items. So when working with data from now until the end of this course, then we will look at each column or each row of our data as a vector, and we will look at the entire data table as a matrix. For example, if you have your data table, and now I will shorten it into this table to make it easier to understand, then my table now has 2 columns. There are only 2 columns, which are birth rate and internet user, and we have up to 5 rows in here. When your database goes into the computer will look at your data table in the form of a matrix like this, a matrix array, and it's all like this. For example, we have 10.244, 35.255, 45, and so on, like a matrix that you learned in high school. Conversely, with a data table, we can also have each row of data. For example, each row in our data will be called a vector. You can see the first row here. This row includes 2 items, 10.244 and 78.9. Similarly, you also have 4 other vectors like the first vector. When talking about a vector, we can show that vector on a horizontal plane. For example, our first data 0. You can show it from the horizontal angle to points 10.244 and 78.9, or data 1. Data 1 here is from the horizontal angle to the point with a degree of 35.253 and 5.9. Then, when you represent the columns, the lines in your data, it can be represented into vectors on a flat surface like this. And this is suitable for using the calculation methods in programming or computer science, because the calculation methods that you will encounter from now on will be the calculation methods based on vectors. To sum up, we will have 2 concepts that we need to pay attention to. The first concept is vector, and the second concept is matrix. Vector is an array of one axis. For example, here we have a row consisting of 2 components, 10.244 and 78.9. This is called a vector. Our vector will have the shape, which is the number of items in the vector, and we will have the dimension as 1. On the other hand, we have a matrix. A matrix is a chain of vectors. As you can see here, our chain includes a large chain. Inside this large chain, there are 5 small chains. And in each smaller chain, we have smaller components like this. Then our matrix will have dimension 2. The matrix will have a shape. For example, in the big chain, we have 5 small chains. Then we will have a shape of 5 here. And each small chain, we have 2 parts in it. Then we will have a shape of 2 in the second dimension. In short, our matrix will have a shape of 5, 2, and will have a dimension of 2 degrees. Usually, you will encounter the vector as a row or a column in the data table. And the matrix, we will talk about the entire data table, 2 dimensions. So why do we need to talk about the concept of vector and magic when we talk about working in Python? Vectorization is the method to optimize the computation of the algorithms that we set up. In programming, we have 2 methods. The first method is single instruction, single data, and the second method is single instruction, multiple data. With the first method, each data you input through an instruction will only be able to generate 1 data output. This method is used in Python lists. When you work with lists, you have to work on each item. You can immediately think that this method is not optimized when we work on large data. For example, if you have a chain of millions of items, you can't wait for single data to go in and single output to go out. Therefore, the second method is better because it allows everyone to input a lot of data and output a lot of data. In the second method, single instruction, multiple data, to do this method, we have to vectorize our data. This method is used in NumPy as well as Pandas, which are 2 extremely important libraries when you work with data. That's why I want to talk about vectorization when we learn about NumPy. So, what is NumPy? I've talked a lot about it. NumPy stands for numerical Python. As you know, Numpy allows us to work on big data because it vectorizes our data and turns our data into multiple dimension arrays. The second feature is that NumPy will help us to perform high-end computing methods as well as using Python functions on our data table. Numpy has three very important features. These three features will help NumPy array perform a Python list faster. First, in NumPy, data is saved directly, and in Python, data is stored by the locations to that data, not directly stored. The second feature is that data in the NumPy array is stored homogeneously. That is, all data put into a NumPy chain must have the same data type. That is, you will have a chain that includes all floats, a chain that includes all integers, or a whole string chain. And the third feature is that by saving your data in the form that all data types are the same. So when you perform a loop or an iteration, going through each data in the NumPy array, and Numpy is the basis of many other libraries that you will learn in data science and machine learning. There are many libraries built on NumPy, so let's see how the syntax in NumPy starts by importing NumPy as NP. In this notebook, we will have 3 parts. No, actually, we will have 4 parts in total. In the first 2 parts, we will discuss the 2 very important factors of NumPy. In the other 2 parts, we will spend time talking about shape and dimension, as well as the syntax to intervene into the NumPy array. The first feature of Numpy, as you can see in the slide, is that Numpy array will work much faster than Python list. So now here we will have a small experiment. In this experiment, I will create a Python list and a NumPy array. Both of these arrays will have the same number of items, which is 10 to the power 6, and all these items will be 0. I will check if these 2 arrays are really equal in length. It's completely equal, guys. When I use assert and nothing comes out, that means I have entered a true statement. And now I will perform an experiment for both of these arrays. I want to add 1 unit to all the items in these 2 arrays. The first is to process on the Python list. In the Python list, we need to do for loop through each item. Because as I mentioned in the slide that the Python list follows the method of single input, single output, right? You can only work on one data at a time. We will do for loop, and at the same time, we will also calculate the time for this experiment. Our task then took 144 milliseconds to run. Similarly, we will add a unit to all items in a NumPy array. However, we don't need to do for loop because Numpy supports multiple inputs, multiple outputs. As you can see, the running time of NumPy is completely faster than the running time of Python list. We only lost 4.34 milliseconds to perform the above test. This is an advantage that is completely superior to NumPy compared to Python list, and that is also the reason why we learn NumPy and we learn the libraries built on Numpy so that we can make use of the speed. So now you will have the question, why Numpy can add a number so easily to the entire array, but Python list does not? The answer to that question is that Numpy performed a move called broadcasting. This broadcasting technique will help you easily perform the calculation methods on an array. Let's go back to the Python list. For example, here we have list 1, which includes 5 items, which is 0, 1, 2, 3, 4. And list 2 includes 5 items like these. Let's say we want to perform a calculation of list 1 multiplied by list 2 like this. You will not be able to do it because Python completely does not support you to calculate on lists like this. However, the opposite happens when we use Numpy arrays. For example, here we will convert the previous list into a Numpy array by using the syntax np.array. We have just moved our list from Python to Numpy like this. Now we can completely perform the calculation by multiplying 2 lists together because NumPy supports you to perform that calculation method. As I said, this calculation method is happening because Numpy supports you to do a move called broadcasting. So, what is broadcasting? Broadcasting is a method that allows NumPy to process arrays with different shapes when doing calculations. Suppose we do a calculation here, an array with 0, 1, 2, including 3 items. We want to do a calculation between this 3-item array with an only number which is number 5. You can see the length of these 2 entities is completely different. One side has 3 items, one side has only 1 item. When calculating, NumPy will support broadcasting, and broadcasting nominally clones this number 5 to make 3 items to match the length of this left array. Now from 3 items plus 1 item, you will have a new calculation of 3 items plus 3 items, and the final result is all the items added together. Similarly, we have a matrix with the shape of 3x3, and on this side we have a single vector. Then these 2 have different shapes. Broadcasting will help you clone this vector of 0, 1, 2, 3 times to become a 3x3 matrix, and can be added to the left matrix. In the third case, we have a vector of 3, 1 column like this, or we can call it a matrix. The matrix has 3 rows and 1 column. And the second matrix is 1 row but 3 columns. These 2 shapes do not match each other at all. However, thanks to broadcasting, it will clone our matrix into 2 similar shapes to be able to add to each other. In all 3 cases, we have just seen that the calculation is optimized and can run because of the Numpy array using the broadcasting method before it starts to calculate. To understand more about this broadcasting part, I highly encourage everyone to read the following guide. This guide is the official documentation of the Numpy library, and in this guide it writes very clearly about broadcasting. So if you want to know more about this broadcasting method, I am more than welcome. I highly encourage everyone to read it. So in the previous broadcasting part, I have repeated a very important concept, which is the concept of shape as well as dimension. This concept you have met in the previous video when I talked about the definition of vectorization. Now we will see more clearly about the shape and dimension in NumPy library. We will have 2 parts. The first part is how you can check the shape as well as dimension of a Numpy array, and the second part is whether you can change the shape of a given array or not. Let's review together a little bit. We have vector. Vector is a one-way array, or vector is also recognized as a row or a column of the dataset, such as you can see here. Vector of 1, 2, 3. Contrary to vector, matrix is a two-dimensional array, or also called an array of arrays. As you can see, the matrix in reality is the data table. Here we have a matrix of 2 dimensions, including 3 rows and 3 columns. In addition to the concept of vector and matrix, you will also encounter 2 concepts that are equally common, namely scalar and 3D tensor. Scalar is a single number, for example, number 1, 2, 3, number 5, number 6, number n, then we will call it a scalar. Scalar does not have a dimension, or we can call it a zero-dimension tensor. Conversely, with scalars, we will have a 3D tensor. That is, when you have many matrices, then we will have a 3D tensor. In the nature of working with the data table with Python, we will usually stop at the matrix. If you learn about machine learning or data science, you will encounter more things like 3D tensors. But for the time being, I just want you to be able to understand the concept of scalar, vector, and matrix. Below are some syntaxes that you can quickly check the dimension or shape of a given array. For example, here we have an array including the number 6. This number 6, as I said above, is a scalar. Scalar then does not have dimension. When you use the .indim method here, it will be 0, and so it has no shape. Vector, for example, here we have an array of 1, 2, 3, 4 transferred into a Numpy array. When you use the .ndim method in this array, then we will have 1 dimension and its shape will be 4. We have 4 items here. Similarly, we will have a matrix. Matrix.ndim method will return 2 dimensions. And then if you want to challenge yourself, you can pause this video and try to guess the shape of the arrays in this example. Our array currently has a dimension number of 3, like the tip I showed you in the previous video, which is to count the number of parentheses here. We have 3 open parentheses, so we have 3 dimensions here. What do these 3 dimensions mean? We will have a large array. In this large array, there are 2 other arrays, 1 array, 2 arrays here. Therefore, in the first dimension, we will have a shape of 2. In each large array, we have 3 items like this. Therefore, in the second dimension, we will have a shape of 3. In each small part, we have 2 smaller items, which is number 1 and number 1 here. Therefore, at the end, we will have 2. So the shape of this array we have is 2, 3, 2. You can pause the video and look at this array and think, or you can rewind and watch this part to understand more. So when there is an array, NumPy will also allow you to reshape this array as long as the number of items you can keep intact. For example, at the beginning, we will have a vector 1, 2, 3, 4, 5, 6. That is, we have a vector containing 6 items. We can reshape it back to a 2x3 matrix because this 2x3 matrix still keeps the number of items as 6, like this. So the syntax is written like this. We will have np.array to convert our list into a numpy array. After that, you will use the syntax np.reshape. Syntax np.reshape will ask you to enter which reshape array you want. I will use reshape array x and reshape it to a new shape. Our new shape will be 2x3, a matrix which has 2 rows and 3 columns. When working with large data, in many cases, you do not know exactly how you want the shape to be detailed. But for example, you want to reshape 6 items into 2 rows, and you do not know how many items each row contains. Now we will go through an equally important problem, which is the intervention in those arrays. And when I talk about the word intervention, it means whether you can enter an array in NumPy and get an item from it or not, or you can replace the value of an item in a NumPy array or not. We are talking about array manipulation. In this array manipulation section, we will talk about 2 issues. The first issue is about integer index, and the second issue is about Boolean index. First, there is a very important thing you need to note, which is that NumPy array is mutable. What does mutable mean? Mutable means you can access an item in the NumPy array and change the value of that item. For example, here we have an array of 3 items, Monday, Tuesday, and Wednesday. Just like Python list, you can use a number index or so called integer index. Like here, I use sample array 0 to select the item in the first position of the array. This is exactly like Python list. And NumPy array, as I said, NumPy array is mutable. For example, here, after entering the first item of the array, you can replace that value with a new value. For example, here I will replace the value of Monday with Sunday. Then you will have a new array of Sunday, Tuesday, and Wednesday. Similarly, as you know in the previous videos, a NumPy array can have many dimensions, or to become a matrix like this, in addition to the index of the first dimension, we also have the index of the second dimension. For example, in a matrix, we will have the number of rows as well as the number of columns. For example, in this matrix, you can see that the values 2, 3, 6, 7 will have the index of the row as 0, 1. In addition, it also has the index of the column as 1, 2. Here, I will expand the syntax from the Python list. In addition to the index of the row, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I will write the index in the form of row first, column second. That is, the index of the row will go first and the index of the column will go after. So now you can pause this video and try to do it. Let's try to choose the area that has values 7, 8, 11, 12 and fill in your code here. Okay, let's do it together. First, you have to initialize the index of the row. Index row of 7, 8, 11, 12 will be 1 and 2, which takes 2 rows. So the index is 1, 2. So I will put 1 and 2 in here, okay? And the column index will be 2, 3. I will then put 2 and 3 in here. oh, we can get only 7, but we can't get 7, 8, 11, 12. One problem here you should remember is that when slicing like this, just like in the list, the number of arrays will stop before the row with this index. That is, if you want to get row 1 and row 2, then we have to write 1 to 3. And if we want to get column 2 and column 3, then we have to write from 2 to 4. Or to summarize this syntax even more, you can write as follows: from 1 to the end according to the number of rows, and from 2 to the end according to the number of columns. We can also take a whole second row by selecting row number 2 and selecting all columns with the 2 dots. Or take the second column by taking the second column and choosing all the rows like this with a dot. In addition, we can also select the columns separately. For example, here I take all the rows and then I just take column 0 and column 3 like this. Then I put the indexes of the columns in a list. In addition to integer index, Numpy also supports a pretty good method, which is Boolean index. Speaking of Boolean, we will talk about true or false. Here we should talk about the fact that you can filter out a certain number of items in the Numpy array using a condition. For example, here if I want to, in this array, list all items with values larger than 5. What should we do? Now let's look at our matrix. Our matrix has the following values. For example, you want to find items that have values larger than 5. When you use syntax x larger than 5, it will return you a Boolean mask like this with trues and falses. Here 1 is not larger than 5, so here is false. 2 is not greater than 5, so here is false. Here the value of 6 is greater than 5, so it is true here. So your question is, how can we return these item values according to the provided condition? You can use syntax as follows. You put that value in a square bracket and you do selection on the array. For example, here, x, then open bracket, then x is bigger than 5 and close bracket. Here you will be returned all items with values greater than 5. In addition, you can also combine many conditions with each other using and or syntax. That is the and condition or the or condition. Here, if you notice the and condition or the or condition, you need to write them using symbols like this. At the same time, you also need to group the conditions using a single pair of brackets. This Boolean index part is very important. You will see this Boolean index part again in the syntax with Pandas library later, and I will explain more in the Pandas library. However, I want to talk briefly about this Boolean index part in Numpy, because it is a rather interesting feature of NumPy that you cannot do with Python list. So in summary, all the lessons in this NumPy part, what are the parts that we need to remember? The first part is that you have to remember what NumPy is and the important characteristics of NumPy that make NumPy different from Python list. The second part you need to remember is that NumPy allows you to perform calculation commands because NumPy has a property called broadcasting to be able to calculate on chains with different arrays. In the third part, you need to distinguish scalar, vector, and matrix, as well as the shapes and dimensions of the given arrays. In the fourth part, we will use syntaxes such as shape and .dim or np.reshape so that we can work with the shapes and dimensions we want. In the fifth part, you need to grasp how the indexes are used in NumPy. It's pretty much the same as Python list. However, now instead of one dimension, you have 2 or more dimensions. And finally, you learn how to use Boolean index in NumPy. Before starting, I have a question for you. Suppose you are given a data block and you are asked to tell a story from that data, or you have to report the insights that you find in that data block. According to you, to go from data to story, what steps do we need to go through? You can pause this video and think about it, okay? Okay, in the data analysis process, we will include 5 steps. If you answer 5 steps, then this is the correct answer. 5 steps in our data analysis process will be followed in order. First, you have to design the question. What is the question here? The question here can come from the people who asked you to do this analysis, such as your superiors or other departments in our company. They have a question and they want to answer that question by using the data. First, you have to determine what you are doing in this project to answer the big question. This is very important because this question will be like a pointer for you in the process of working. If there is no question, you will swim in that pile of data and you do not know where you are swimming, what you are swimming for, and you do not know how you will swim to get to that shore. The first and most important thing for us is to design a big question for your project. After you have determined what your question is, you will then begin to collect data. Here, you may already have that data, the company already has and shared that data with you. Or in many cases, you have to collect your own data, you have to go online to find different sources, or you have to ask some other departments to have access to the data you need to answer the big question I asked at the beginning. After you have the data you need to answer the first big question, the next step is to clean up the data you have just collected. According to my work experience, this step is the most time-consuming step, but at the same time, it is also the most important step of the 5 steps here. Why? Because when you collect data, then surely your data will always have errors both in terms of format and in terms of meaning. There are cases where your data is poor or your data is repeated or something is wrong. Then in this data cleaning step, these are the steps that you will filter the data that you have been collecting. In data analysis or in machine learning, there is a very good quote that is garbage in, garbage out. That is, if your data is not good, then your insight output will also not be good. Therefore, this clean data part is one of the primary and most important parts in the pipeline of 5 steps to work with data analysis here. You will have to pay attention to this part. After the data cleaning step, we will come to the 4th step. This step is the step where you will kind of cook the data. We will use a term EDA here, which is the acronym for Exploratory Data Analysis. Here you will draw charts, you will analyze and draw valuable insights that you think will be able to answer the questions that you set out at the beginning. And finally, the last step is not least important, which is to report. What is a report? After you have the insights, you will build a dashboard or a presentation full of persuasion so that you can give the insights you have just found to the parties that ask you to analyze this data. Above are the 5 steps from question design to report. Please note these 5 steps. And our lesson from here until the end of this course will also be attached to these 5 steps. From asking questions, to collecting data, to cleaning data, data analysis, and finally report. On the 5-step path in data analysis, there are a lot of tools that can help you, support you in your work. Here I can give some options as follows. For example, in the data collection section, you can store your data on hosting services such as Google Drive, Dropbox, or Google Cloud Service. Or you can also store it in a SQL database, such as in DB files, or store it on BigQuery. In addition, we also have a service called NoSQL. They use the language NoSQL to work and store your data. We have many options that you can use. In our lessons, we will use Google Drive and Dropbox as well as GitHub to use as a place to store data. To add a little more here, this data storage usually depends on your company. Each company will use a different service as well as they will have a different data system. Therefore, one of the steps that I often do when I first enter a new company is to contact and find out from the people in the company where they store the data. What is the structure of the data, as well as the access and navigation around that data? Then we come to the clean data and EDA step. In this step, with our lessons, we will use Google Colab. Google Colab, as you know, is an open and free platform that will help you use Python code to work with data. In addition, you can also see some of you will use JupyterLab. JupyterLab is similar to Google Colab. However, JupyterLab will be installed on your computer and can be used offline. Finally, in the report step, we will use Tableau. I think those who study in my course will be very familiar with tools like Tableau or Power BI, or maybe Google Data Studio. In our course, we will learn Tableau and how to use Tableau to be able to design a really beautiful dashboard, along with the platforms that I just mentioned, which will help you do tasks in data analysis such as hosting services, Google Colab, and Tableau. We also have Python library tools that will help you work on it. For example, in the data collection process, as you have learned in the Python module, you have the beautiful soup library which helps you to scrape data. You can collect data from the internet. In the clean data and EDA part, when working on Google Colab, we will use the Pandas library for data analysis. In addition, we also have the Matplotlib library and the Seaborn library to help you visualize data. When I put out these platforms as well as libraries here, they are not separated. Why? Because here I use the word pipeline. This word pipeline is very important, because when we go through these 5 steps, we will not do these 5 steps separately from each other, since the output of this step is the input of another step. For example, after you have collected data, the data you find will go to the clean data section. And after you have completed the clean data, that clean data will go to the EDA section. Therefore, these 5 sections must be continuous, and we will use these services continuously to build a complete pipeline. For example, here from the hosting service, we can connect to Google Colab using the syntax of pandas, for example, pd.read_csv, to load the data from a CSV file into Google Colab to work. Or we can use pd.read_SQL to load a file in database format and read it by SQL and load it in Google Colab. You have met this before. I don't know if you have noticed that when you do SQL exercises, you will see a line called pd.read_SQL, and then you type the SQL command to work on Google Colab. Or you can also export the file from Google Colab into CSV so that you can load it on Tableau. These steps and these platforms can be connected to each other to build a complete chain called pipeline. As you can see here, we use Python and Python libraries a lot in data analysis. Some of you will ask me a question. In addition to Python, are there any other tools that can do it? And why do we have to use Python for data analysis? As you know, for example, Excel can also do these tasks. Excel can also collect data, clean data, also EDA and other things. But why don't we use Excel? There are 2 points that I find extremely important for why we use Python and Pandas here. The first advantage is immediate output. When you run the code on Google Colab, you will see the result immediately, almost in nanoseconds, in less than a second. For example, here I have a code to draw a map. You can see that when I run Google Colab, it will give you the map very quickly, extremely quickly. This will speed up your data analysis ability. Your project can be completed in a very short time. Secondly, and this is an advantage that Excel cannot have, that is the ability that you can go up from data analysis. You go up to machine learning. You build a model that predicts your data. You can go up to the machine learning field only when you use Python, you use code, then you can use machine learning. These are the 2 advantages that I find most important. Why do I use Python in data analysis? So I've been talking a lot about it. So what is Pandas? First, it's not this panda is an animal. It's not a bear. Pandas is a library. Please note this word. It is a library built on the Python language platform. As you know, in Python, there are many different libraries that do many different tasks. For example, the beautiful soup library to collect data, the NumPy library to do math on numbers. Now you have the Pandas library to work with data. Pandas has a very good feature, that is, it can read data from many different types. As you can see here, you can read data in CSV format, you can read in the form of an Excel file, JSON, or even SQL. You can work on Pandas, and then you can create a new database. There are three very important data types in Pandas, called the three components that make up Pandas, that all Pandas learners need to hold on to. That is data frame, series, and index. Data frame is the data table. You can look to our right-hand side as an example of data frame. This data frame includes the countries and the recorded data of those countries. For example, Afghanistan here has the country code is AFG, birth rate is 35.25, and internet user is 5.9, which is classified as low income. As you can see, a data frame is a data table made up of many rows and many columns. Therefore, data frame is called a two-dimensional table because it has two dimensions. The first dimension is the rows, and the second dimension is the columns. Usually, when you load data from a data table, your data will be displayed in a long form. Later, I will learn more, then you will know that there is also a wide form. In the long form, you often see that each row can be called by another name, observation, and each column is also called feature or variable. Later, if you study further through books, documentation, I hope you won't be confused when you come across words like observation, feature, or variable. I will repeat, each row in our data table can be called an observation. Each column in our data represents a property of that data, so it can be called a feature or a variable. For example, in the data table here, we have a column called Congo. Here is an observation of Congo. And in Congo, there are properties, namely country code, birth rate, internet user, and income group. The second type of data that you will see in Pandas is series. If data frame is two-dimensional, series is then one-dimensional. So what is series? When you get a line or a column from a data, then now your data will be in the series form. Or down here, you take out a row, which is the Aruba row, then here your data is in the series form, one dimension. One thing to note is that each series is only allowed to have one and only one data type. For example, when you get a data column, all the data in this column are now in text form. You can't have one column in Pandas that has many different types of data, and this is extremely easy to understand. For example, if you build a system to record data for your business, for example, your balance sheet, all data in your balance sheet can only be in the form of numbers. It can't be both numbers and words, right? That's the nature of series. Each series can only have one and only one data type. How can this row have only one type of data? If you extract this row of your data, Panda will automatically change this line to the same type of data, which is text. Even if you have a number here, all in this line will be returned to the. You can notice on the left-hand side of the table contents section. When you click here, you will be able to see the structure of our notebook if you don't know. Today, in this notebook, we will first cover the read and overview data using Pandas, and the second part will be to work with data frame. Some of the first syntax to work with data frame. First, read and overview, similar to other libraries in Pandas, in Python. Before you use it, you have to import Pandas as PD. After you wrote this import line, the Pandas library has been imported and is saved to the PD variable. Then, to load data in Pandas, you will use the pd.readcsv method. Just use the pd.readcsv method here. And then you can input a link to your data. Here I'm using Dropbox to save my CSV file. When you run this code, the pd.readcsv method will load your data and give you a data frame. Here the data frame will be saved in the variable called df. When you call the df variable, you will see the data table like this. This is the example I used before to talk about some of the features of Pandas. Our table includes the countries and the characteristics of those countries, such as country code, birth rate, internet users, and income group. Recently, Google Colab also has a very interesting feature for your data table, which is that you can view your data in a more beautiful way if you click on this symbol. It will give you a more interactive version of your data. You can go to the next page. You can quickly filter in some of the features in your data. This is a new feature of Google Colab, and I find it quite interesting and very intuitive. Now, we will go to some of the basic methods of Pandas that help you to grasp an overview of the data after you load it. We have three methods: head, tail, and sample. The head method will give you the first 5 rows of data, review the first 5 rows of data. The tail method will help you review the last 5 rows of data. And the sample 5 method will help you give out 5 rows of any of our data. For example, if you want to change to show 10 rows of data, you will .head 10 here. Very simple. One thing you should note here is that my syntax will be the name of the data table and .head, not pd.head, but the name of the data table .head. Here is df. You will see that this structure is repeated a lot in the following syntax of Pandas. Because my database is named df, so I will call df.head. If your data table is named Coder School, for example, the data table is Coder School, then our syntax will be Coder School. Head 10, for example. It depends on the name of the data frame that you call these methods. The next two syntaxes that I often use when I just load some data, the first syntax is df.shape. This df.shape method will return you the shape of the data frame. Your data table has 195 rows and 5 columns. Here you see 195 rows and 5 columns. Please note that df.shapes here does not have parentheses. This is its syntax. It does not have parentheses here, so pay attention to this. And the last syntax is df.info. df.info method is an extremely useful tool. It will let you know a lot of information about our data. Normally, after loading data, I will immediately use df info to view the general information in my data, so it tells you some of the key structure of your data. It tells you that our df is currently a data frame, or in a data frame form. Our data frame has 195 rows with index running from 0 to 194. You can see 195 rows with index running from 0 to 194. For you to know, it includes 5 columns that are country name, country code, birth rate, etc. In each column, the number of non-null data that is not null is how many. Here we have 195 data, and each of these data is in what data type? Because we discussed the other day that each column in a data frame can only have one and only one data type, right? Here, our data type is an object or text for the country name, and similarly, the country code. The birth rate is in the float form, and the internet user is also in the float form. And finally, a small piece of information, that is, your data table has covered how many bytes in your memory. You can see the method df.info is extremely useful in the process of overviewing our data. In summary, I will import pandas. I will read using pd.read to read my data. In addition to read CSV, you also have other methods such as read SQL, read Excel, depending on your input. We have 3 methods: head, tail, and sample. To quickly look at a number of rows of data, we have shape to tell you how many rows and columns our data has, and we have info to print out a small information table about our data. There are only 5 columns here, so you may still haven't seen its usefulness. But you can imagine that our data has more than 30 or even 100 columns. Then the information overview of your data frame here will be extremely useful. We will choose how the data is, how the syntax is. Now we will look at our sample data, the data about countries as well as the properties of those countries. Let's talk a little bit about indexes. As mentioned in the previous lesson, in each data frame we have 2 types of indexes. The first index is the row index, and the second index is the column index. Therefore, the data frame is also called the 2-dimensional table, because it contains one dimension, which is row, and another dimension, which is column. To extract the names of the row indexes, you will use the syntax df index. The df index method will return you the name of the indexes, and df.columns here will return you the name of the columns. For example, here our table has indexes from 0, 1, 2, 3, etc. When you execute the command df.index, it will return to you that your index is in the range from 0 to 195, with step equal to 1. And the df.column method will return to you the names of the columns country name, country code, birth rate, internet user, and income group. One of the operations that you may encounter when working with data frame is, if you do not agree with this numerical index, you then can choose to set a column or make a column in your data frame to become an index column. For example, in this data frame, you want the country name to become an index column. Because your country name is independent countries, no country is duplicated. So you want to use the country name as an index column. We will use the syntax df.setIndex. You will use the syntax as the name of your data frame and then .setIndex. And you want to set the index of which column. For example, here I choose the country name column. Now you will see that instead of numbers from 0 to 194, the country name replaces those numbers and becomes an index column, and its row has become also called the row index. You will see since then, numerical indices have been replaced by the country name as the index for the row. However, one thing you need to observe is that when I call my df back, I did remember to change the country name into an index column, but it's still the same as before. Please note that this setIndex method is not recorded in your data table. It is not recorded in your data table, but it creates a new object here, but it is not recorded in the original table. If you want to record to the original table, we have to write an additional parameter called inPlace. The syntax will be inPlace equals $true. That is, it will record into your original data frame. For example, I run this code and then I will check the data frame again. Okay, now you see we have set the country name as the index column and recorded it in the original data. Please note that this is a mistake that many of you when beginning to learn pandas will make. In addition, you can read more about other parameters of this function in the documentation link that I included here. When you learn how to code, especially with Python, you should practice the ability to read documentation. If, for example, you don't remember what setIndex is, you can Google setIndex documentation pandas, for example. Each syntax in Python will usually go with a user guide called documentation, for example, here. And in there, you will find the parameters that you can input in that function. For example, here we have inPlace is Boolean, so it can be true or false. If it is true, it will interfere with the original data frame, not create a new object. In addition, we also have some other functions, and when you drag it down, pandas is very nice. In addition to writing how to use it, it also gives you some illustrations. I see that this pandas is very good at documentation, so you can refer to it. On the other hand, with the setIndex, we have the resetIndex. Now our data has country name as index. If you don't want country name as index, then you can reset index. And now country name will be a new column, not an index column anymore. Cases when you want to choose a data point or a piece of data in data frame using indexes, and how to use that syntax. Talking about indexes in data frame, index in data frame has a very important property, which is that it inherits the property of Python list and also inherits the property of dictionary. Inheriting the property of dictionary, the indexes here are written like keys. For example, Aruba, Afghanistan, Angola, Albania, those are row index. The index column is also written in this table. It is called explicit index. Do you remember it? It is like the key of the dictionary. In addition, when you load a data frame into Pandas, Pandas will silently set numeric count for each row and each column. For example, the first row will have the index as 0, the second row will have the index as 1, etc. Similarly for the columns, Pandas silently does this. Those 0, 1, 2, 3 numbers are implicit indexes. That's why we say that Pandas index has both list and dictionary properties. From those two properties, we will have two syntax groups to select data in Pandas. One is that you will use explicit index, which is the index that you see in the table. And one is that you will use the implicit index or numbers as 0, 1, 2, 3, 4, like list. These two ways are the same, only the syntax is different, but its purpose is completely the same, so you can use whichever syntax is most convenient in your case. First, using explicit index. Looking back at the table I have, for example, now I want to find the line with the index as Vietnam. Then I will write df.lock, df.lock, here means location, df.lock, and I write the name of the index in. You see what the name is on this table, then you write that index in here. For example, here I don't choose Vietnam, but Angola. I will write it as I see it, like that. After you run this code, it will return the data to you in the row with the index is Angola. I remind you here, you will use the .lock method and you will write the index name that you need to extract into it. And this index name will be the same as the name you see on the table. For example, this row has the index name Angola. Then I write it as Angola here so that I can extract the row with the index name Angola. Suppose now you want to choose many rows, both want to choose the row with the name Angola, but also want to choose the row with the name Vietnam. Then you have to write those index names into a list and put that list into the syntax.lock. If you only choose Angola here, then we have a pair of squared brackets and Angola. However, now, you also want to choose Vietnam. At this time, you have two names, then you have to put these two names into a list. Then the square brackets inside it marks a list, and the outside bracket follows the syntax of the .lock method. You need to distinguish this, okay? You have taken out two rows, one is the index of Angola and the other is the index of Vietnam. So I have a small question for you. According to you, the return result of this syntax, what is its return result? What data is it? This result is a data frame, series, or index. You can pause this video and think, okay, the answer is the return result from this syntax is a data frame. Why is it a data frame? Because according to the definition, many rows and many columns combine with each other. It will create a data frame with two dimensions, rows and columns. Or if you want to check this, you can use the syntax type in Python to see what the result is. Then we will have a data frame type. Or a little trick I want to show you. That is, if you see that the table has a beautiful dark print like this and it has a hover effect like this, then it is a data frame. And a series will print a bit ugly like this. You can get it. So now we have just used .lock to choose a row or choose many rows. Suppose we don't want to choose a row, but we want to choose a specific data here, which is 45.985. What should we do? Now let's look at the data again. Syntax.lock will help you first call the index of the row. Here I have Angola. Okay, 45.985. When I look at its column, I will see that it has an index column called birth rate. I entered birth rate here. I will then locate 45.985. To select a specific data in Pandas using the .lock method, you will write .lock, and the index row will go first and the index column will go after. Suppose here you select df.lock Vietnam and internet user, you will get the result of Vietnam, internet user of Vietnam. Or here we want to find Albania and the birth rate of Albania. Oh wait, we have a mistake. Why is my syntax not running? Let's think about it. One of the very important properties here is that index is case sensitive. I repeat, index is case sensitive, which means where to write capital, where to write it normally, you have to write it exactly the same way. Birth rate in our table does not have the letter R capitalized, but below we have the letter R capitalized again, so the syntax does not run. Here I will fix it, just like on the table. Then I will have Albania, and birth grade is 12.877. And you can also combine many rows or many columns. For example, here I choose the area that has the line index is Angola, Vietnam, and Turkey. In addition, that area also has the internet user and birth rate. You notice that when there are many row indexes or many column indexes, I do the operation of giving those index names into a list like this. A separate list for the row index and a separate list for the column index. Then you will have the table in the area you want. Easy, right? I just need to call the table name and .lock. Then we will specify the name of the row first. If you want to choose a whole row, then you just need to enter the name of the row. But if you want both the row and the column, then we will enter the name of the row and the column name. In the case that you have many row names or many column names, then you will put the row names and the column names in the list like this. After you have learned how to select data areas or a data point that you want, I want to introduce you a little bit about slicing. Slicing, that is, you want to select the data section from position A to position B. You want to slice that whole area. You can use the .lock method here, and you use the two dots for slicing, just like a list. For example, here I want to select the areas that have data, the name it goes from Aruba to Albania. Like this, let me introduce to you guys from Aruba to Albania. It will cut this section out, and it gives you the name from Aruba to Albania like this. A small note, if you slice in the list, it will stop before the last point you write. However, if you slice with the .lock, it will always get to the last point. That is, it will take it all from Aruba to Albania. Or in other words, here I will get the rows from Aruba to Albania. However, I only use 2 columns, country code and birth rate. Or you can also use the syntax of choosing all the rows and the column named country code. Here you choose all the rows and choose only country code. However, if you want to choose all the rows and only one column, or you just want to choose each column, you can write the syntax easier, which is df, and then write the name of that column. Here, you don't need to use .log or .iloc, which you will learn about later. When you choose a column and all the rows in that column, you just need to simply df, then open square brackets and write the name of that column here. Similarly, if you want to choose many columns, then you will put the column names in a list like this. I choose only the country code, and here I choose both country code and internet user columns. There have been quite a lot of syntaxes here. If you're confused, please pause or replay this video so that I can listen to this example again. In short, the first method is .loc. This method is similar to dictionary. Why? Because after the .loc, you will have to write the index that you can see on the table. You can use .loc to select a row or select an exact data according to the name of the row and the name of the column. You can use it to select many rows and many columns. You can use it to slice many rows. If you want to choose all the rows of a column like this, you can write a simpler syntax like this. And it also supports you to choose many columns. In general, the .loc method is that you use the index name that you look at the table to select data. For example, here I see that the index is country code, so I write country code here using .loc. If .loc uses the name that appears on the data table like this, then .iloc will be similar to list indices. It will use the 0, 1, 2, 3 numbers that Pandas silently digitizes when you load the data. For example, here, look at your data. The rows are like this. To choose the line called Angola, you will call syntax as df.loc and input Angola. However, if you write iloc, then now you have to input the number. Angola corresponds to 0, 1, 2. Angola here corresponds to the index with the number 2. Therefore, you type the number as df, iloc2 to return to the Angola row. These two syntaxes all return the same result. Therefore, you should choose a syntax that is suitable for your situation. Use any syntax that is more convenient for you. There is no advantage here. Note that .loc method will use the direct index and iloc method you have to use numbers. Just like .log, the method, iloc also helps you to choose a correct data point. Suppose I want to choose the data point 45.985. Then if using .loc, you need to determine the name of the line index, which is Angola, and the index code, which means birth rate. Then at this time I have to choose the number. Then Angola is at 0, 1, 2, and birth rate is at 0, 1. Therefore, to choose 45.985, we have to take the row with index 2 and the column with index 1. Then you will have the syntax, which is df.iloc. You then choose the row with index 2 and choose the column with index 1, and you will get the number 45.985. It's completely the same as .loc. However, at this time you do not input any words in it, but you put the number that you count on your data. In addition, iloc as well as loc methods also support slicing. For example, here I slice by row, from row with index number 1 to row with index number 3. And here is from the first column to the second column. You can also choose your data area. That's all about iloc. Pretty easy, isn't it? Iloc is different from loc, in which if in log you use in the column name you see on the table, here in iloc you have to input number 0, 1, 2, 3.